Okay, so then what is the first rule for tracing is that if any ray, let's say this blue one, is coming parallel to the principal axis, something like this, then it will be reflecting back, obviously. Then where will it reflect back? It will reflect back through the focus point. Let's say this one is the focus point, then the reflected ray will be passing through the focus. Only in the condition when it is parallel to the principal axis. This is the principal axis, the black one, and this blue is parallel to the principal axis. In that case, it will be reflected back and it will be passing through the focus. This is the case of the concave. But what happened in the convex one? Let's say the line is again parallel to the principal axis, and again it is going to get reflected back, no problem, but it is not going to pass like this. It is not going to pass like this, no. Instead, what will happen, because the convex mirror it is, so that ray will be getting diverged something like this, but we will imaginary extend it up backward something like this, and we will say that this backward extended up line, imaginary backward extended up line, which will be passing through the focus. So in the case of convex, it is not a true focus, neither these lines are actually meeting at the focus, these are imaginary, while in the case of convex they are actually passing through the focus. Now you can also draw a line in between them, something like this. You know, this one is the incident and this one is the reflected one. If I draw a normal from here to from the pole, if I make a normal something like this, then we know this angle will be the incident one and this angle will be the reflected one. Similarly, in this case also, if I make a normal from the mirror something like this, then this angle will be like this. We can say one of the angle will be the incident one, while one of the angle will be called as the reflected one. So in the second rule, what is happening? In the first one, if there was one line and which was passing parallel to the principal axis, it was coming through the focus. But in the second case, what will be happening? Let's say that one line is coming from the focus, something like this. Then where it will be going? It will be reflecting. Obviously, it will be coming something like this. One second, why I'm not able to make it like this. Then it will be reflecting, right? It will be reflecting from this point. And now what will happen? See, in the just opposite of this case. In this case, it was coming parallel and moving towards the focus. While in this case, what will happen? It is coming from the focus and go parallel, just opposite of that of the previous case, something like this. While in this case, what will happen? Let's say one line is coming through the focus. Now if I'm saying that one line is coming through the focus, will it come from behind the mirror? No, it will not come behind the mirror, but we will say some line is just appear to come from the focus. It will come something like this. And where will it reflected back? Again, it will be reflected back parallel to the surface, something like this. So if we will extend up the incident light in this case, in the case of convex, if we will extend up the line, it will appear to meet at the focus. That's why we consider that in this case it is coming from the focus only, and this is getting reflected back parallel to the principal axis. Now, as I was saying about normal, that in this case, see, the if this is the focus, if this point is the focus, then just double of this I have to make the center of curvature. Let's say somewhere over here, right? This, if this is the f, then the center of curvature length is just doubled, right? So if I will make a line which will be passing through this point to the mid, that will be said as the perpendicular. And in this case, we know which one is the incident one. This one is the incident one, so this will be the incident angle, which is in between the incident light and the normal, and this one will be the reflected one. Similarly, you can make for the convex also. Let's read the definition also, that a ray passing through the principal axis, principal focus, a ray passing through the principal focus. We see one line is coming which is passing through the principal focus of concave mirror. After reflection, will emerge parallel to the principal axis. I have written will over here, right? So what will happen? One line which will be coming through the focus will reflect back in the parallel to the principal axis. While what is happening in the convex case, it just appears, right? It just appears that it's coming from the focus. We will move to the third point now. Copy it. Okay, so now what is happening in this point is that, let's say this is our focus, and if this is the pole and this is the focal length, then our center of curvature will be just double to the focal length, let's say over here. It seems like it is more than the double, so we can make it somewhere over here. Now let's say one incident light is coming, and that incident light is passing through the center. Now it will get reflected back because this is the incident one. And as for all the images we are making, the reflected one with the red one, let's make this one also. So we will say that it is passing through this same point. It is retracing the same point. It will be passing to the center once again. If you know the laws of reflection, from that we know this thing, that if a line is passing normal to the reflecting surface, then it will be retracing the path. In the case of the convex one, what will be happening? In this case, actually it will be not passing through the center of curvature, but again it will be appearing so. So if I make one line over here, let's say some line is incidenting like this, okay, and if this is my focus and this is my reflecting center, then it will be something like this. And we assume that it is going towards the center, or it is coming from the center of curvature. In that case, we will say that this line, wherever it was coming from, it will be going to the same path. And this will be the case of the convex one. This is the focus, this is the center of curvature, this is the focus, and this is the center of curvature. Let's go to the definition part once again, that a ray passing through the center of curvature of the convex mirror, or directed in the why we have used this directed in the directed in the, oh, there is some problem. Directed in the direction should be there, not directed in the directed, but it should be directed in the direction of the COC, that is center of curvature of the convex mirror. So what is happening in both of these cases? The line is passing through the center of curvature, and after reflection, the reflected light will be passing through the same point. Now, if someone asks you that why is this thing happening, then your answer should be because the light which is falling, the incident light which is falling, is coming along the normal to the reflecting surface. If there is any point something like this, then, and this is the normal, if the incident light is coming towards the normal or along the normal, then it will be going through the same point, something like this. Now quick copy it so that we will move to the next point. So let's understand what the last rule is. The last rule is that if any line which will be coming to the pole obliquely, something like this, such that it is making an angle, right? It is making an angle from the principal axis, or we can say to the principal axis. One second, let's make it something like this. So we see this angle, right? This is our angle of incident, which is the angle in between the incident light and the principal axis. Now it will get reflected back with some angle again, and which will be reflected obliquely again. And we say that this angle I will be equals to the angle R from the law of reflection. I is equals to angle R. Similarly, what will happen in this case? In this case, see, there is nothing happening beside the mirror, everything in front. One line will be coming like this, making some angle I, it will be getting reflected back, something like this, making some angle which will be R, and angle I will be equals to angle R. So let's come to the definition part also, that a ray of light incident obliquely to the principal axis towards the pole, it is coming towards the pole. Now it is joining, these two lines are actually at the same plane, and that is the pole. Either it can be of the concave mirror or the convex mirror, is reflected obliquely such that the incident ray and the reflected ray follow the law of reflection. What shall be the law of reflection? That incident angle is equals to reflected angle. Also, these two lines should be falling on the same plane, right? And this is what the four laws are. Now we will be understanding about the image formation by the concave mirror first.